Now we're recording. So it says we can use the powers to show repeated multiplication. The power button, or the actual exponent, this number 5 has a job. His job is telling you how many times to write the base. So it's saying you need 5 bases of the number 2. So you need 5 2s. So that's what it's actually telling you. You need 5 2s. That is called your repeated multiplication. They used an X as a time sign. What should they have used?
The little circle.
Big fat dots. So those should have big fat dots on them to be time signs. Okay.
Or decimals. Or however you pronounce it.
Yes.
That's good.
Okay. So you read 2 to the 5th as 2 to the 5th power. Here's another example. Let's use example 3 to the 4th power. 3 to the 4th power. How would I write that as repeated multiplication? Hands up, don't holler no, please. How would I write that as repeated multiplication? 3 to the 4th power. Yes. Good. So how many 3s should I have? 4. Exactly. I should have 4 3s. And what is my answer? Try and figure that one out. What would your answer for that be? How big is that? The back? 81. Good. That's 81. Perfect. And how big was 2 exponent 5? Who can find that answer? How big is 2 exponent 5? 32. Good. This guy equals 32. Okay. That is called our standard form or decimal form. Standard form or decimal form just means it wants the answer. Okay. Let's move to the next page. This guy's telling us repeated multiplication. Here's our power, and we read it. So it says 1 factor of 2. What should this look like? There's 1 factor of 2. This number, the one that tells you how many of them there are, that's your exponent button if it tells you how many there are. So what should this guy look like? Just a 2, good. Or 2 exponent 1. They could show you the hiding 1 there, and that's okay. What about 2 times 2? What would this one look like? 2 times 2. Good. 2 exponent 2. And we would call that 2 to the 2nd or 2 squared. If it's got an exponent 2, it actually has a special name. We give it squared. What would the next one look like? Yes, it's 2 cubes. So 2 to the 3rd or 2 cubed. So they get special numbers. Squared and cubed have special numbers. And we say them very special. This one here, we've got 2 exponent 4. 2 exponent 4, we would say 2 to the 4th power. There's no special name for 4th power. Okay. It just goes on, yeah? Now, if I wanted to write how much they were, if I said evaluate means solve. All right. Well, 2 to the 1st power is just equal to 2. What is 2 squared equal to? 4, because I would take 2 times 2, so that is equal to 4. What is 2 cubed equal to? What is 2 cubed equal to? Not 6. Nice try, though. 8. Yeah, you're not adding, you're multiplying them. Okay, and then I need the last one, 2 to the 4th power. 16. Good. What should the next one be? 32. What are they doing? What is the pattern every time? What are they doing?
Goes up by 2, and then like it goes if after you hit 8, it goes up by 8.
Well, what you're doing is you're multiplying the number before by 2. If I take 2 times 2, I get 4. Times 2, I get 8. Times 2, I get 16. I would times by 2. So the number we times by is the base of the exponent. Okay, the number we multiply is the base of the exponent. All right, so I would be multiplying by 2's here because it's the base 2. Okay, let's take a look at the next section. Let's write these as powers. So how would I write that one as a power? What would A look like? Quiet, please. You should have it at the very bottom of that page. How would you write 4 as a base power? What would that look like, that one? What would A look like? 4 with a baby 6. Good. So 4 exponent 6. That's written as a power. How will we do B? What is B going to look like?
5 to the 7.
5 to the 7th power. Good. What about letter C? What does C look like? Yeah, just a 3, but what does he have hiding? He's got a little baby 1 hiding there, okay? Don't forget. Do you have to write it? If it wants to see the power, yes, you have to write his little power. Okay, if it says write as a power. Okay. -2 times -2 times -2. That's going to give me a -2 as my base. How many of them do I have?
3.
3, good. So I get -2 cubed. All right, you guys try those 4. Okay, who has A? Let's go to the corner over here. Yes, there.
7 to the power of 4.
7 to the 4th power, good. Who has B? Corbin.
8 to the. Do you say 2 or 7?
Doesn't matter.
2
8
of power?
squared or to the 2nd. We say squared or 2nd power. Okay, what would this guy be? -10 exponent how big? -10 exponent how big? Good, to the 4th power. And the last one, letter D. How big is letter D?
5 to the
Good. 5 to the 1st power. Good. All right. Let's take a look at the next section. Now we want to write as repeated multiplication and standard form. Repeated multiplication means we want to expand it. So repeated multiplication is called expanded. And standard form is called the answer. We also call it decimal form, or decimal form. Okay, so it is called expanded for repeated multiplication, and standard form is our answer, or we can call it decimal form. So it's got a couple different names. So on letter A up here in example 2, how am I going to write 2 to the 4th power? I want to have it repeated multiplication and the answer. What am I going to write for the first one?
2 times 2 times 2.
Good.
And
And it equals 16. Perfect. Absolutely. The second one, letter B. How big is letter B going to work out to be?
5 times 5 times 5, and the answer is 125.
Good. 5 times 5 times 5 is 125. Perfect. All right. I'm going to give you a couple minutes. You guys fill the table out, please. All right. So what is standard form for the first one? What is our answer for the first one? In the back.
8.
8. Excellent. Let's take a look at the next one. How many 6s am I going to write?
6.
2 6s. Good. 6 times 6. Our answer is 36. The third one down. 3 exponent 4. Yes, sir?
You're going to write 4 3s.
4 3s. Perfect. And how much does 4 3s times by itself give us?
81.
81. Nicely done. Okay, let's look at the bottom 3. All right. Josiah.
10, like 4 times,
10 4 times.
and then 10,000.
And that'll be 10,000. Good. I put a slash to the 0 so you can tell it's a 0, not an O. We do a lot of things with letter O. So O's and zeros are different. Yes, sir.
8 times 8.
Good. 8 times 8, because squared means 2 of them. And that's going to give me how big? 16. Excellent. Or sorry, 64. What are you talking about, Miss Tuck? 64, that is. 8 times 8, not 8 plus 8. Okay. 7 cubed. 7 cubed. No, let's try it.
7 times 7.
Good. 3 7s. 7 times 7 times 7. And how big is 7 times 7 times 7?
147.
Nope.
343.
343. 343. All right.
I should have known.
Let's move to the next section. Now we're going to see the 3 different things that we talk about when we talk about area, perimeter, we talk about length, We talk about one-dimensional objects, two-dimensional objects, and three-dimensional objects. We can see here that a one-dimensional object is just talking about length. It's just talking about a line. Only a line. We talk about two dimensions, we get area, we get length times width, or we get base times height. So we have two sides, two dimensions. On a cube, there are three dimensions, length, width, and height. So that's our volume, and we have units cubed. Now, what is the hiding exponent on our centimeters? It is exponent 1. Okay, does everybody remember that? Okay. Do we have to ever draw the 1 on him? No, he usually hides. Okay, now we're going to see, this is what each of those look like. These are one-dimensional. These are lengths. So if I take a look at one-dimensional, 2 exponent 1, well, actually, I've got how many 2's? I've got a length that is 2 centimeters long. Okay, you can see half of it here, half of it here, so I've got 1 there and 1 there. 1 plus 1 is 2, so that line is 2 centimeters long. How long is this line? 3 centimeters, 4 centimeters, 5 centimeters. Good. They kind of look like number lines with ticks, don't they? Okay. These ones again are showing us the exact same thing, only now I've got area, length, and width. So I've got 1 times 1 for length and width. So this is my length, and this is my width. Length times width. Same thing over here. I've got length times width. I've got 2 here and 2 here. And on the bottom, same thing. I get 3 and 3, length times width, and 4 times 4, length times width again. So those are two-dimensional. Again, I'm multiplying two numbers, length and width. That's why it's two-dimensional. Three-dimensional is volume. Now we're talking about length, width, and height. So now I've got length, width, and height. And that's what each of them are. Length and width and height. Every single one of them. So, length, width, height. This little baby 3, the exponent's telling us I have 3 dimensions. Length, width, and height. So length, width, and height. Same thing. Any confusion with dimensional objects? No. The one we use for perimeter is which dimension? Dimension 1. Perimeter is always dimension 1. This is length. This is always perimeter. Okay, so if you go back to dimension 1, that is always perimeter. Perimeter is dimension 1. It's only talking about length. Okay, so what other words do we use for length? We could use perimeter. What does perimeter mean? Distance around
Well, if you go perimeter,
an object.
two-dimensional.
No, you're just counting the length of everything. Length, 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 length. You're all adding lengths, right? Okay, that's what perimeter is. You're adding the length of objects. Okay, so if it was perimeter of this room, I would add the length of the width, the length of the height, the width. So the width and the length, they each get a different dimension. So I would know how big this room is. Okay, if I wanted area, I would multiply those dimensions, length and width. But here, I would just find the distance around. What is distance around a circle called? Circumference. Good. So circumference is also a one-dimensional, and that's perimeter of a circle.
And it's like what we consider a sphere.
Yes, it would be. A sphere, it's a ball. Absolutely, for 3D. Okay, so one-dimensional, we get perimeter, which is distance around, and we get circumference. That's specifically for a circle. Okay. Now we're almost done this lesson. We can take a look. You guys, I want you to figure out what these would be. Please write those as powers. All right, who's got the top left? Top left. All right, Seelan?
3 squared.
3 squared, absolutely, because we have a 3 for length and width. What about the one on the right here? What will we get for this top right-hand one? Top right hand.
2 cubed.
2 cubed, good. Each side is 2 and 2 and 2. Excellent. On the middle left here. This one. Sure. Good. 3 to the power of 1. That's just one dimensional. It's a line. This one on the right-hand side. What do we have for this one? Let's have a volunteer. I'll pick a victim. 1 squared. Perfect. We have 1 by 1. Okay, on the very bottom. What do I have on the bottom there? Bottom left. Yes, sir. 1 cubed. Excellent. Length, width, and height. All ones. What about this one right here? I think I forgot to put some notches in it. There's my notches.
Oh,
Sorry, I made some notches for you. I forgot notches on there. Okay, so what's this guy going to be? Hands up, hands up. Yes, ma'am. Good. 4 to the power of 1. Excellent job. Okay, now we're going to draw them. We're going to draw what each one of those represents. So if I want to draw 3 squared, what is this telling me is my length and my width to draw? I would go 3 as a length. So here's my width is 3, or my length, and width is 3. Okay, so width is 3, length is 3. And width and length can switch, they can be whichever way you want. Okay, so I've got 3 and 3. How would I draw the 4 times 4? What would I do there for 4 times 4? What do you think 4 times 4 is going to look like? Okay, he's going to be 4 squared. So that means I've got a length and a width that are 4. So I need to find 4 and go 4. So I've got 4 and 4. Well, this is 4 exponent 1. 4 exponent 1. What would 4 exponent 1 look like? Well, if I'm drawing a square, I know that 4 to the 1 is a line. So what could make 4 as an answer if it was square, if it was a square? What could give me an answer of 4 if I had to draw a square?
2 times 2.
Excellent. So this is actually 2 times 2, or 2 squared. So now I'm going to find a length and a width of 2. So this is my 2 by 2. And it's telling us to draw squares. Okay, so they gave us an exponent 1. When they give us an exponent 1, that means there's 2 numbers that multiplied to give me that number. Okay, so we have to find it. Now, what was a good way we could find this number? What is the opposite of the squared on your calculator? Square root. So all I had to do was square root the 4, and I would get 2. Okay? Square root the 4, you get the 2. If it was volume, you would cube root to find the number that multiplied by itself 3 times. Absolutely. If you have a number that has a hidden exponent 1 on it, and they say it wants to make a square length and width, you must square root this to find the length and the width. Okay? Or like we did, you think of 2 numbers that multiply to give you that answer. Okay? All right. Let's move on to the next section. All right. What is our base? What we're going to do is we're going to circle our base, and then we're going to evaluate. Evaluate means solve it and find the answer. So this means solve and find the answer. Okay, so what is 4 squared going to give me? Which one is my base in 4 squared? Hands up, please. Which one is my base? The 4. So I'm going to circle my 4, and now I'm going to solve it. So in your calculator, you're going to go 4 times 4, or hit 4 and then the squared button. What is 4 times 4 going to give you? 16. Thank you. Okay. Let's go across to letter B. 8 cubed. Which one is my base? The 8. Perfect. And now we're going to go 8 times 8 times 8. And what do you get for an answer? 512. Very nicely done. Well, let's take a look at letter C. we have a negative 2 in brackets, exponent 4. So that means I've got negative 2 4 times. So the way we would put that in our calculator is you would go bracket, negative 2 bracket, exponent 4. Now, you don't often have exponents in your calculator, so you have to look for a button that looks like this, y to the x. If you have a button that looks like y to the x or x to the y, that's your exponent button. So what you do is you would put bracket, negative 2 bracket, and then hit your y to the x, exponent, and then 4. Okay?
No answer to that, like, no answer to that, like, there is.
Yes, we're going to answer it. That's what I'm telling you to do right now. I heard somebody whisper it. It is 16 all day long. Okay? Now, I can do this 2 different ways. I could group the numbers. I could group them like this. I could take and I could say, okay, well, I know 2 times 2 is going to give me 4. And I know that 2 times 2, whoa, trippy. Okay. I also know that 2 times 2 over here is also going to give me 4. So now I'm going to have 4 times 4 is how big? 16. So there's different ways you can do this without even having to use your calculator. Okay? Yes, sir.
I'm sure everyone knows, you know, since it's negative, it has to be like, you have to identify that's a positive.
You absolutely are correct. Now there's rules with negatives, and we're going to take a look at our negative rules. They're coming up. We ended up getting a positive answer here. Does anyone want to take a guess why we got a positive answer? Why did we get a positive answer? Okay, a negative and a negative gave us a positive 4 here, and a negative and a negative gave us a positive 4 here. Absolutely. Yep.
In relation to what Kaylee said, that's basically the rule. When you have 2 identical
Bases.
yeah, basically be it negative or positive, you're going to get a positive no matter what. You know?
Absolutely. You are right. That's the negative answer rule. Absolutely. Okay, but what happens this time? Take a look at that one. Type that in your calculator and see what you get.
That's not a negative, is it?
It is a negative sign. You betcha it is. But there's no bracket, so type it in the way you see it. So you're going to go negative 2, y to the x, 4. Enter. Negative 16. So this is going to give us negative 16, not a positive. So I get a negative answer here. Does anyone want to take a guess why this would give me a negative answer and the other one gave me a positive answer, but they both have the exponent 4? Go ahead, try it.
Bracket. I don't know.
Okay, let's see if Josiah can help you out.
When you have a negative sign, everything that follows is negative unless there's brackets separating them.
You are absolutely correct. This negative is called a floater negative. So what this actually looks like is negative 1 times 2 times 2 times 2 times 2. So the 2 is our base, the 2 is positive. It's a positive base. But there's a hidden negative 1 here timesing by it. So this floater negative is always a negative 1. Now floater negatives will always make a negative answer. So if I, for example, had a floater negative in front of letter C, I would get a negative answer as negative 16. Okay, so floater negatives always make your answer negative. Negatives in brackets depend on how many of the bases you have. Okay, let's look at the bottom. You guys try those 4 questions on the bottom yourself, and we'll see how you do. Okay, we're going to take a look. 3 exponent 4 we found should give us an answer of 81. When we put a negative in brackets here, we're also going to notice it gives us 81, positive. Without the brackets down here, we get a negative 81. What does 5 cubed give us? 125.
I like how nobody's putting their hands up anymore.
Okay. Well, there was a couple people, but
You've already given up.
we're not giving up. Okay. Now we're going to go talk about our negatives, and we're going to talk about the rules with our negatives.
Yep.
Okay, now we talk about negatives inside brackets and negatives without brackets. Are they different? Yes, they are. We already discovered that. Is there a rule that can help us? Yes, there is. The first rule says negative bases with an even exponent. So a negative base will always be in brackets if the base is negative. That's what the brackets are telling you. The base is negative. That means the exponent will be outside the brackets. If it's an even number, you'll get a positive answer. This will give me a positive 4. This guy will give me a positive 81. And the following one on the bottom here is going to give me a positive 1. Okay? How come? Because my exponents are even numbers. Now, take a look. Negative bases in brackets. So in brackets, always. With an odd exponent, 3, 5, 7, 9, 11, all the odd numbers. If it has an odd number, it will give you a negative answer always. This will give us negative 8. 3 exponent 5, what's 3 to exponent 5 going to give us? Negative 200 and
100 and 205.
negative 243 it should be. Try 3 exponent 5. 3 exponent 5. That should give you 243. Because the base is negative, but we have an odd number exponent, we're definitely going to have a negative answer. Same thing on the bottom. I have a negative 1 in brackets. And I notice it has a 7 odd number exponent. I'm going to have a negative 1 for an answer. So, with negative bases in brackets, you look at the exponent. Is it an odd number or even number? Even number is a positive answer always. Odd number is going to give you a negative answer always if you've got an odd number exponent. Those are the rules. Well, then how do we deal with negative signs without brackets? And that's what this talks about. It says negative 7 squared doesn't have a negative base. The base is actually positive 7. The negative sign is not affected by the exponent. The negative sign is a hidden negative 1, is what it actually is. So it's called a floater negative. We call it a floater negative. And it always makes a negative answer for your exponent. So, since you know you have a floater negative, do you even have to put it in your calculator typically? No. All you know is that your answer is always negative. Now you put in your calculator 4 squared, you will find 16. 4 cubed, 64. And the last one, was there any others? No, I think we're good. Okay. You've got the rest of the period. I'd like you to finish where it says student practice try these. Please do page 10 and 11.